Hello everyone, I hope you are doing well, especially to our precious lecturer Dr. Norzita binti Jamil. My name is Nur Shahira binti Muhammad Isa, matric number 284997. I am a student of Bachelor in Science Economic with Honours. In this presentation, I am going to walk you through some explanation on Assignment 5, Introduction to Mathematical Economics. So, I'm going to discuss the concavity, marginal cost function, revenue function, cost function, and profit function. Let's start with question 1a. Question asks to determine where the function f(x) equals to x cubed minus 6x squared plus 18x minus 15 is concave upward and where it is concave downward. If you want to see whether the function forms a concave downward or concave upward, we need to find the second derivative where we need to find the first derivative first. Okay, so the first thing that we need to do is differentiate f(x) function by using the formula of power rule as shown. The first derivative was 3x squared minus 12x plus 18. After that, we have to find the second derivative of f(x) and the answer is 6x minus 12. Then, for the step 3, we need to let second derivative function equals to 0 to identify the open intervals. And the answer is negative infinity to 2 and 2 to infinity. And for the last step, we need to test the number of each intervals. We can choose any number as far it fits the intervals. For the first interval, we use test point 1 and we need to substitute it into second derivative function and we got negative 6, while for interval 2 to infinity, we got 6. It means that interval negative infinity to 2 is concave downward because it less than 0, and for 2 to infinity, concave upward because more than 0. For question 2b, suppose that the cost function for a manufacturer is given Cx equals to 0.000001 x cubed minus 0.003x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. Question 1 asks, find the marginal cost function. What we need to do is differentiate the cost function because we know that C prime x equals to MC and we will get the MC function 0.000003x squared minus 0.006x plus 5. For question B2 Roman, describe the behavior of the marginal cost function, whether concave upward or concave downward. The steps are similar with the previous question. Step 1, we need to find the first derivative of MCX and we got 0.000006x minus 0.006. Then, step 2, we need to find the second derivative of MCX and the answer is 0.000006. It means that MC function of this question is concave upward because it is more than 0. Next, we have to let MC prime x equals to 0 to identify the critical point and the value of x is 1000. Lastly, we must to substitute it into MCX function to identify the other critical point. So we can conclude that MC function forms concave upward at critical point 1002. Let's move on to next question. Question C. A company has established that the revenue function in Ringgit Malaysia is 2x cubed plus 40x squared plus 8x and the cost function in Ringgit Malaysia is 3x cubed plus 19x squared plus 80x minus 800. Question 1 asks, find the level of production that will yield a maximum profit for the company. Before that, we need to find the profit function. Total revenue minus total cost, and just substitute the information given into the profit function and we will get the answer. Negative x cubed plus 21x squared minus 72x plus 800. Then we need to find the first derivative of px using the power rule, and the answer negative 3x squared plus 42x minus 72. After that, we have to find the second derivative of px, which we will get negative 6x plus 42. After that, we need to let p prime x equals to 0 to find the level of production. After we factor out the function, we will get two answers, which are 12 and 2. To find a maximum profit, we must substitute 12 and 2 into the second derivative of px, where for 12 the answer is negative 30, which it is maximum. Whereas we substitute 2 into this function, the answer will be 30, which is minimum. We can conclude that the production level of 12 is the profitable of the company. For the last question, C2 Ramen, find the price per unit to maximize the profit. Firstly, we must find the price function, Rx divided by x, and after that, just substitute the value with the given Rx function into price function, and we will get the answer 2x squared plus 40x plus 8. Next, tab 2. We have to substitute 12, which is the level production that maximizes the profit, into p function, and the answer is 776. So, the price per unit to maximize the profit is 776 in Ringgit Malaysia. That's all from me. Thank you for your attention. I hope you can enjoy while watching this video.